You know that feeling when you're just drowning in information and you can't figure out what actually matters? Well, today we're going to dig into how scientists tackle that exact same problem, how they find truth in a world that's just buzzing with interference.
Yeah, it's kind of like trying to have a conversation at a really loud party, right? You know the person you're talking to is saying something, but all the other chatter and the music just makes it almost impossible to pick out their voice. So how do you focus?
And you know, that phrase, finding the signal in the noise, it's not just a nice metaphor for our crazy lives. It's a real, fundamental challenge that scientists and engineers face every single day. So, what's their secret?
That whole struggle for clarity, well, there's a precise scientific framework for it. And once you get it, it doesn't just make science seem a little less mysterious. It actually gives you a powerful new way to think about finding clarity in your own world.
Okay, so let's dive right in. To really understand this battle for clarity, we first need to meet the two main characters in this story, the signal and its very annoying companion, the noise.
So, first up, we've got the signal. This is the good stuff. This is the actual data you're looking for, the message you're trying to get, the one true thing that tells you what's really going on. It's the voice you're straining to hear in that loud room. And then there's the noise. Noise is all that other junk. It's the random, chaotic, messy information that just gets in the way. It hides the signal. It can even mess with it. It's all the other conversations, the background hum, all the stuff that makes the real signal so hard to find.
And here is the absolute key takeaway. Noise is fundamentally random. It's just part of our universe. You can work really hard to reduce it, to shield against it, but you can never ever get rid of it completely. It will always be there.
So, since you can never totally eliminate noise, scientists figured something out. It's not about the absolute amount of noise you have. Nope. What really, truly matters is the relationship, the ratio between how strong your signal is and how strong the noise is.
And this is called the signal-to-noise ratio, or SN for short. You can just think of it as how much stronger your signal is than all the random junk around it. The math is basically the average strength of your signal divided by how much the noise fluctuates.
So why are we looking at the number 3? Well, in the world of science, a signal-to-noise ratio of 3 to 1 is like the absolute minimum, the gold standard. Think about that for a second. If your signal isn't at least 3 times stronger than the background noise, you can't really say for sure that you've detected anything real. It could just be a random blip.
So if you want to improve that ratio, you have to know your enemy. And it turns out, not all noise is the same. Scientists have to battle a few different types, and they all come from different places.
The main culprits usually fall into 3 big categories. You've got chemical noise. Think of that as unwanted side reactions happening in your experiment. Then there's instrumental noise, which is noise created by the actual machine or tool you're using. And finally, environmental noise, which is just all the interference bleeding in from the world around you.
And even within instrumental noise, there are different flavors. You have something called white noise, which is like a constant low-level hiss that's just always there, across all frequencies. It's caused by things as small as the random motion of electrons in the wires. Then there's noise that's stronger at certain frequencies, and that can cause weird stuff like your measurements slowly drifting over time.
And this right here is a perfect picture of environmental noise. This is a real map from inside a university lab. Every one of those spikes is a specific frequency of interference. You can literally see the 60 Hz hum from the power lines, you can see noise from AM radio stations, and even those low-frequency rumbles from the elevator going up and down. It's everywhere.
Okay, so we've met the villains. How do scientists actually fight back? How do they make that precious signal of theirs stand out from all this chaos? Well, they've got a pretty powerful toolkit of strategies.
It really boils down to 3 main approaches. The first one is just good old control. Physically isolating the instrument, shielding it from electrical interference, keeping the temperature super stable. The second is a really clever trick called signal averaging. If you take the same measurement over and over and over again, the real signal adds up, but the random ups and downs of the noise, they start to cancel each other out. And finally, there's filtering. That's where you use software or hardware to just digitally cut out the noise at specific frequencies, like that 60 Hz hum from the power lines.
But you know, when you get right down to it, every single one of those techniques has one and only one goal: increase the signal-to-noise ratio. That is the name of the game. Period. And the takeaway here is that every little improvement you make to that ratio, whether you go from 3 to 1 to 10 to 1, or from 100 to 1,000, it gets you a more precise measurement. It pulls you one step closer to seeing the true picture of reality that was hiding under all that noise.
So once you understand this tug-of-war between signal and noise, and you know there are tools to boost the signal, you kind of have a blueprint for finding clarity. It's not about trying to find a world with zero noise. That's impossible. It's about getting better at listening for the signal. So the question is, what are you going to do to find yours?